Okay guys, so in this video we are going to review a practice exercise about box and whiskers plot and cumulative frequency graphs. So here's the first part of the situation. It says that a study was conducted to compare the height of a group of students from two different schools, and the collected data were as follows. For school A, we had these 8 values, and for school B we have these 8 values as well. We are asked to draw a box and whiskers plot for each group to compare them. Find the interquartile range for each group and draw conclusions about it, and write a general conclusion about the comparison of the distributions. So let's start basically gathering the information that we need in order to create the box and whiskers plots. So I am code with green school A and maybe with blue school B, so it's easy for you when you watch this video. And remember, for in order to create a box and whiskers plot, we have to basically find 5 values for each set of data. So for school A, we will have to find the minimum, the quartile 1, the quartile 2, which is also the median, the quartile 3, and the maximum. Okay, and the same thing for school B, but let's do it first for school A. So what I told you in class is that um, whatever thing you do in order to basically solve the problems and answer the questions, write it. And specifically for this example, we need to know that in order to find these 5 values, the set of data has to be organized. And in this case, this set is not organized, so let's actually order it. As usually we do it from smaller to smallest, sorry. So the smallest value here in the set of data is 148 centimeters. So 148. The next is going to be 149. Next is going to be 150. Then 152. 153. 155. 157 and 160. So we have 1, 2, 3, 4, 5, 6, 7, 8 values as it should be. Remember guys, if there are repeated values, you should write them as many times as they appear. So what's the minimum? In this case, it's 148 centimeters. What's the maximum? 160 centimeters. And for the quartiles, Q1, Q2, and Q3, we should start with Q2, which is also the median. And it also determines the other two quartiles. So remember, after the data is organized, you have to find the middle of the set. In this case, since the set is even 1, 2, 3, 4, 5, 6, 7, 8 values, we know that the half of the set is going to lay exactly between two of the numbers. So what's the half of 8? The half of 8 is 4, so we know that the half of the set is going to be in between the 4th and the 5th values, exactly over here. So remember, when this happens, we do this addition, the addition of the two, 153, and we divide by 2. In this case, it's exactly 152.5 centimeters. Okay, great. Don't forget to include the operations that you do, even if you do it with you do them with calculator during the exam. Um, Anyone that is tasked with reviewing an exam will look for the processes as evidence that you actually understand and you didn't get the answer by chance. Now for Q1, the first quartile, we need to follow a similar process but with the half, the bottom half of the set. So with this part. Since the median is exactly between these two, it's like hidden here. We use everything that is before that. So we include the 152 in this case. So same process, it's even, it's 4 elements in this half, so the half of 4 is going to be 2, so we know that the second and the third values are going to be used in order to determine quartile 1. We have to do exactly the same, 149 plus 152, and then divide by 2 to get Q1, and it's exactly 149.5. And for quartile 3, same thing, same story. We know that these two values are going to determine the median. So 155, sorry, plus 157 divided by 2, and in this case it's exactly 156. Okay, this operation results in 156. We have the 5 values that will help us to create the box and whiskers plot for this set. Sorry, so for this group of children, school A. But we have to compare it with school B. So before plotting the box and whiskers plot, let's find the same 5 numbers but for school B. Now let's do it. Don't forget to reorganize the set if it's not in order. So for school B, the smallest value in this case is 147 centimeters. The next one is going to be 151 centimeters. Then 153. Then 154. Then 155. Then 158. Then 159. And then 162. 1, 2, 3, 4, 5, 6, 7, 8 values as it should be, so we didn't miss anything. Again, minimum 147, maximum 162. So Q1, Q2, which is the median, and Q3, they all come from this set. Remember, it should be organized. If you don't organize it, you will most likely get the wrong values. Okay, again, this is a set of 8 values. The median is in between the 4th and the 5th values. So again, don't forget to write the operation 154 plus 155 divided by 2. In this case, we get 154.5 centimeters. Since the median is here, we take everything from before to calculate Q1, the first quartile, and half of this half is in between these two numbers. So again, same operation, 152 plus 153 divided by 2. In this case, the result is 152.5. And for this, is between these two, 158 plus 159 over 2, which is 158.5. Those are the 5 values. Now, let me make this thing a little bigger. I don't know, I forgot how it's possible. Here. Okay, good enough. So bear with me because I am going to do the box and whiskers plots on this side, but if you are able to use grid paper or even millimetric paper or graphing paper, try to do the graphs or anything that you are asked as accurate as possible, because that's the purpose of having that kind of paper. Okay, if it's a white canvas like this, it's okay, but if you have gridded paper, be as accurate as possible. So if we are going to compare two box and whiskers plots, the most convenient thing that you can do, oh, I think I can have a grid. The most convenient thing that you can do is to plot them over the same axis or scale. Remember, one of the most important aspects of box and whiskers plot is a proper scale to reference the spread of the groups. So let's try to find or determine a scale that works for both box and whiskers plots. So this one comes from 148 to 160, and this one comes from 147. I don't know why I wrote this wrong. 147, excuse me. 147, yeah, to 162. So the exact smallest number that we are using is 147. You can start from there, but since I like working 2 by 2, so I am going to start with 146. 146. I am going to try to do this as small as possible. 146, 48, 50, 51, sorry, 52, 54. I think it's too small of a scale, so let's try to do it one by one and let's see if it works. 146, 47, 48, 9, 50, 151, 152, 53, 4, 5, 6. I think one by one works in this case. So yeah, one by one. Okay, 147 goes here, but I am just going to skip this and write 148. 150 here, 152 here, 154, 156, 158, 160, 162, which is our maximum value for both sets, and 164. It's not necessary to go over there, but since I had already the axis, like the scale, elongated enough, it's also okay. So again, school A, I'm gonna do it with green. Okay, green. Minimum 148, exactly over here. Q1 149, which is here, 0.5 is going to be Q1. Q2, which is the median, 152.5, approximately over here. In your paper you will have like the chance to do it even more accurately. Q3 156, and maximum 160. Exactly. So remember, the line doesn't cross the whole thing. It only goes from the point, the edge of this whisker on the edge of the box. Excuse me. Let me actually do it properly straight here, here, here. This one also goes until here, and then excuse me, we close the boxes. Well, the whole box. Sorry. Oh my god. This is not working properly at all. Yeah. Fine. By the way, after you correctly plot the box and whiskers, don't forget to label each one of the parts. And I don't mean Q1, Q2, that's not what I want. What we want is to be able to gather as much information, as possible from the plot. So it's 148, 149.5, 152.5, 156, and 160. And now I'm gonna do the same with school B. Okay. Oh, by the way, don't forget to label here school A, here height, in centimeters, and school B. Let's actually do it over here. So once again, minimum 147. I'm going to do it over here. Q1 152.5. Median 154.5. So over here. Again, you will be able to do it even more accurately with your graphing paper. This 158.5 over here, and the maximum 162. So again, it's okay. Don't forget to label. Excuse me, I made a mistake, because this is in 148 and it should be 147. So let's actually correct it. Okay, I'm going to do it just like this. I'm gonna try to erase this. Yeah, more or less. Now let's label 147, 152.5, 154.5, 158.5, and 162. All in centimeters. So now we have we can start our comparison of these two groups of people. So just from the graph, you can see that school B is way more spread, because like both have the same amount of people, but the range of school B, which is the maximum minus the minimum, is longer, is wider, is greater than the other one. You can see it with the graph, and if you find the ranges numerically, you will also appreciate it. Now, we can actually see that school B is positively skewed in comparison to school A. What does it mean? That the distribution is going more to the tallest side, or it's distributed more towards the tallest than school A, because school A is distributed more towards the smaller people, and that is negatively skewed in comparison with school B. So let me write it somewhere over here. So that's part of our conclusions. But you are also asked to find IQR, which is the interquartile range, and that's found really easily with a formula. The interquartile range is basically just subtracting Q3 minus Q1. Okay, so Q3 is 156 and Q1 is 149.5, and the result of that is 6.5. Okay, don't forget to write the operation even if you do it with calculator. Examiners will always look for evidence of your understanding, and operations are part of that. So that 6.5 tells you something. Remember, interquartile range is this minus this. That tells you the length of the box. And remember, in the box, there are 50% of the values together or distributed across all of these section. Remember, this is 25% of the people, and this is 25% of the people. So the interquartile range is the range that those middle 50% occupy. Now let's do it with school B. Okay, for school B, the interquartile range is 158.5 minus 152.5, which is okay, let's do it because I don't want to mess it up. Let's do it by hand. You will have your calculator, so don't worry. 5 minus 5 is 0. This is 6. Okay, yeah. It was 6. Okay, that's the distance. Let me check something here. Okay, this is 6.5. And this is 156. Yeah, perfect. Yeah, 6.5, and this it's 6. Oh, there's a mistake. So guys, before I realize it, before I tell it, let's try to analyze what the mistake was. Okay. Okay. I'll give you some time, like some seconds, to realize what our mistake was. Clue is around here, because since we did this exercise in class, the result didn't look fine for me. I remembered a different result. And yes, it was different. Because the Q1 in our case is calculated wrongly. Look what happened. 151 and 153 are the numbers that determine Q1 in the school B. Look what happened. I didn't write this number properly, and that's why I got a different result. It should be 151 plus 153 divided by 2, which is exactly 152. I'm sorry for that, kids. Mistakes happen. And since I promised you this video today, there's no chance to do it again or to edit it. So let's correct it. If I do it properly now, 152 minus, sorry, 158 minus 100 and, sorry, oh my god, I forgot how to talk. 158.5 minus 152, it's exactly 100 and, sorry, 6.5. And look, we got exactly the same interquartile range. Remember, interquartile range tells you the range where the middle 50% of each group is spread. And if it's the same, it means that both boxes measure exactly the same. They occupy the same length. What's the difference? Again, this one is positively skewed and this one is positively skewed. But we can conclude that the distribution of the middle 50% of both groups is really similar. Okay, they are equally spread across their respective ranges. Okay, what's the difference? Once again, this one is skewed more towards the negative side, like to the smaller heights, and this one is skewed more towards the taller heights. Okay, I'm not going to write the conclusions, but please take into account this explanation, and if you want to watch it again, it's fine, it's a video. Now, let's continue. Let's continue because that's not it. That's not the whole thing. Let me check if it's still recording. Okay, we are almost to the half-hour mark. It's fine. It will take a little bit more. Okay, still same situation, but an additional school to consider. A third group, school C, provided the information of the heights again in a frequency chart. Okay, and this is organized in intervals. This is grouped data. So we know, I am going to cut it with red, this one. We know that in between the heights of 150 centimeters and 152 centimeters, not including the 152, that's only the limit, there are three people. What are their exact heights? We don't know. We just know they are in this range. Okay? So, frequency 3. Cumulative frequency still 3. So far, we have accounted for 3 people. But now, from the range of 152 centimeters, including the 152, to 154, there is only one people. Sorry, one person. Excuse me, again, I forgot how to draw. Sorry, how to talk. You see, you hear. But the cumulative frequency in this case is 4. Because remember, cumulative frequency is the total amount of people that we have counted so far. So, here, so far, we only accounted for 3 people. But here, we accounted for these 4 people. In this range, there are 3 people, and in this range, there is one person. The cumulative frequency in this case, now, it's 7. Because so far, here, we accounted for 7 people, and here, for 8, so the cumulative frequency is 8. Okay? That's it. We have 8 people in this set. Same amount that these 2 schools. Well, we have to complete the table and create a cumulative frequency graph. So, remember guys, there's a very important difference between the cumulative frequency graphs and the other type of graph that we use for the normal frequency. For the normal frequency, we have to use a histogram, that, remember, it's just like a bar graph, but with the bars together, no gaps between them, because it's grouped. So we account for the intervals here. Yeah, 150, 152, 150 to 154. Okay, and the amount of people in each individual range, sorry, interval. That's a histogram. But since we want to use a cumulative frequency graph, it's a little different. It has elements in common, but it's not a histogram. It's a cumulative frequency graph. I'm not going to write the whole thing. And it's similar in some ways because you have to also label the same ages. Or, sorry, by the way, here's the frequency. Here's the, in this case, height. And here it's the cumulative frequency and also the height. And it's also organized in intervals, but then you draw a curve. Okay? That's way different. Okay? And we use the cumulative frequency, not the normal frequency. Well, let's do it. Let's graph them. Let me go back a little bit so I make erasing all of this. Okay, and let's actually also erase this and write the numbers properly. So, well, 3, 4, 7, and 8. No more clutter. Okay, let's do it. Again, axis. Well, I can do it in black. Vertical axis, we have the cumulative frequency, and let's design a scale already for this. So since we are counting only up to 8 people, it's a fairly easy scale. 1, 2, 3, 4, 5, 6, 7, and 8, more or less. No more. I can erase a little bit here. Let's actually do it like that. Give me a second. Let's actually use the grid for clarity. Let's do it over here. 1, 2, 3, 4, 5, 6, 7, 8. Let's erase this part. And let's label. Don't forget to label the things that you graph. If you don't label, you are leaving out the way that you have to actually understand the information that is presented. Okay, now in this axis we are graphing the height, and remember it's grouped, and we start in 150, so we can make this little mark in order to represent that there's like heights that are smaller than 150, but we are not counting them. We are not using them. So 150, excuse me, I will need to make this bigger so I can, oh my god, I think I made a mistake and I made it too low. Okay, let's try to do it as good as possible. 150, 152, I am going to use 3 squares. No, actually, let's use 4, just in case we want the exact half of it. 154. Here, 156. I need to make it a little bit longer. and 158 centimeters. Oh my god, this is too awful. Please don't do it as awful as this one. So again, cumulative frequency and height in centimeters. Please don't do it as awful as I'm doing it. Okay, again, now, cumulative frequency, don't use this. This is for the histogram, the one with bars. This is not the one with bars. This is the cumulative frequency graph. It's a curve. Okay, from 150 to 152, so far we have 3 people. So on the 152, the top limit, the top boundary, we have to put the point for 3. On 154, we have 4 people. On 156, we have 7 people over here. And on 158, we have 8 people. Okay? Let's do the curve. Please try to do as smooth as possible curve. Please don't do it like me in the exam. This is just a really late night video for you, as I promised. Okay, so now, estimate the quartiles using the graph. So, you can really quickly estimate the quartiles using the graph, but there's a really common mistake that people do when they're doing that. Also, I am going to explain how to find a more accurate estimation of the quartiles. Remember, it's still estimation because we are working in intervals, group data, and we don't have the original 8 values, just their intervals. Okay, if you want to quickly estimate the quartiles, we are going to focus on the axis of the cumulative frequency. Most common mistake, you do it from this axis when it's the opposite. Okay, so 8 is the total amount of people. And we are going to begin with Q2, which is the median, okay? Which is exactly in the half of the group. So what's the half of 8? 4. So over here, it's the 4th value. And let's see where it intersects with the curve. Exactly over here. We are lucky, we know that 4 is exactly here. So that will be Q1, okay? Q1, well, probably better to write it on the edge, not just here. Okay, that's Q, excuse me, another mistake. That's Q2, the median. Q1 is later. Q1 is from 4 to 0. From 4 to 0, the half is 2. So we do the same. We intersect it with the curve. Don't go past the curve. And then when it touches the curve, go down exactly perpendicularly. That's Q1 actually. This is Q1 really, not this one. This. And same story for here. From 4 to 8, middle exactly 6. Let's intersect it with the curve. And that's Q3. And if you want, at the end you can like also draw this for the maximum value. It's not necessary. So now with this you have an estimation of the 5 numbers that we used to also create a box and whiskers plot. And here you can see the distribution. You can see the same distribution that we had in a box and whiskers plot, but from the cumulative frequency graph. You see that, like for example, this quartile from the minimum to Q1 is closer or is tighter together, is less spread than this one or than this one. Well, this one and this one looks pretty similar. Remember, it's still an estimation. And this one, like the top 50%, sorry, the top 25% is way more spread, look, than the other 25%. Maybe not this one, but again, let's not move more into that. Okay, that's an estimation. Again, estimation, not exact. Okay, it's not it's not wrong, but it's not perfect. If you want a more mathematically accurate estimation of those things, we will have to use the median. But since this is cumulative, sorry, since this is continuous and group data, we will have to use the version for group data, okay? And for that, we need to establish a class mark. I don't know if you remember, guys, kids, or guys, just when we talked about class marks, okay? Sorry for this mess. Class mark. Okay, so remember, the intervals are the classes, and the class mark is exactly in the middle of these two values. So, how do we calculate the class mark of this one? 150 plus 152 over 2, which is exactly 151. This number is going to represent this class. Here, I'm not going to bother with writing this process, but the class mark here is the middle between 152 and 154, which is exactly 153. Here's 155. You can check it if you want. And here's 157. With these class marks, we are going to go. Let me reestablish this. We're going to go and calculate the median of the set. You are lucky, guys. You are really lucky because the median is basically same than in not group data, just like taking into account the class mark. So what is the class mark of the middle? Okay, let's use these four values. Do we have a value in the middle? No, we don't. But we can calculate the middle value between these two. Again, with 153 plus 155 divided by 2, which is exactly 154. That will be Q2 or the median. Let's see if it corresponds. Yeah, we did it exactly. 154. Now, what about Q3? We take these two. Remember, if it was a wider set of data, you should make sure that it's the two values in the middle of this half, just like when we did this, but with class marks. Again, Q1 would be 151 plus 153 divided by 2, which is 152. Okay, we actually didn't estimate it properly. This is a more accurate representation of what that number should be. Okay? And why is that? Because we didn't do a really good curve. Okay? And even if we did, remember, this is still estimation. We are understanding and representing this information without all of the 8 original values. So that could happen. What's better? This is the better representation. And now let's do Q3, which is the middle exactly between these. And it's between these two, 155 plus 157 over 2, which is 156. Well, it was this. This one was also a little off. Remember, it's completely fine. It's okay. It's okay. This is not completely. This was not completely accurate. This is an estimation. This is a better estimation. Still, we are not sure if those are the exact quartiles because, once again, we don't have um, the original 8 values, just the ranges where they lie, and that's it. Without, you can do a really similar conclusion um, that we did with the box and whiskers plot, but just using other type of representation. And with that, I will end this video because this is a way longer video than I expected. Look, 45 minutes. I hope it's useful for you. I don't know if you will watch it completely, and I don't know if you stand my stuttering and mess with writing, but I hope it's really useful for you. So have a nice weekend and see you on Monday.